Hello, everyone, and welcome to my talk today, Emotional Intelligence, where I'm going to tell you all about how to build smarter animations. My name is Nick Butcher, and if this would click onward. Hello. There we go. My name is Nick Butcher. I am an engineer on the Android developer relations team, and I focus mostly on UI design and development, so I spend a lot of time on the main thread. I'm going to go through a lot of code today. This is I/O. That's what you want, right? But don't worry about taking photos of the slides or worrying about referring back later. All of this talk is going to be uploaded later to this URL, or if you're watching on the recording, you can find it right now, hopefully. So you can follow along, and there'll be gists of code and everything. So today, I want to talk to you about animations. I think animations are super important. #animationsmatter. Often, I think animations are thought of as delight or polish or something sprinkled on at the end of the development process. And I think that's a massive shame. And I think that contributes to the reason why they're often the first things on the chopping block when time is tight and features are crunching. Animations, I think, are really important for usability of your application. They can explain a state change so that the user knows what's going on. They can establish a spatial model so that you have a sense of place within the application. Or they can hint at how you can interact with them. So they're very important, in my opinion. But I think animations are currently under threat. And that's due to changes in the way that we're architecting our applications. So there's a movement towards having the controller of your application be outside of the view layer, right? And something like a view model then publishes a state of the application. So a UI model, view state, whatever you might call it, is essentially the entire state of your application needed to render on the screen. And as things change in your backend, say a network request comes in, or the user performs an action, an interaction, this updates the state in your view model, and you publish a new version of this UI state. There's lots of benefits to this kind of architecture, such as being able to reason about the entire state of your application at once, or easier testing, and so on and so forth. But I'm not going to go into those today. I'd encourage you to check out unidirectional data flow, or patterns such as MVI, or even libraries such as Mavericks or Mobius for helping to implement this. What I do want to talk about is the observers of this stream of data at the other end. So when you get these stream of UI models, you then need to bind it to your, into your views to set these values to set up the state of your views. Now, having the stream of UI models is kind of like a pure function. You want to have this like pure input and perform an action. It essentially wants to be very stateless. On the other side, animations are essentially very stateful. They want to know they're all about setting a value from one value to another value over a period of time. So this, I think, is the ultimate tension right now. With this move to this new architecture, it's becoming harder to kind of join these two stateless and stateful worlds. So today, I want to focus in on some tools and some techniques that you can use in your applications right now in order to enable you to do animations. Because I think it's a shame. I think a lot of people are finding it hard to kind of square this circle, to kind of marry these two models. And as such, I think animations are under threat. So to look at these kind of tools and techniques, let's start off with a simple minimum viable screen where we have some kind of logon form. And when you hit logon, crucially, I want to hide the login button and show some kind of progress spinner, but I don't want it just to blink out of visibility and change. I want it to animate out and the spinner to animate in. So the UI model, the state for this screen might look something like this, a simple data class with a couple of booleans about what's going on. And you can then bind this into your view layer, to your application, using some kind of library functions like this, where set visibility in this static world before we animate it does something very simple, like setting the view's visibility based on that Boolean state. So how can we animate something like this? So a initial kind of naive way to do this might be something like this, where we're just running an animation to, in this example, fade in a view. Or when we're fading it out, we have to, of course, set the visibility to gone, because otherwise the button stays present in the hierarchy, receiving touches and so forth. So we all know this. We're all Android devs. We have to use the alpha property and then set the visibility as well. But doing something like this might yield to interesting results. Like, for example, just doing that is actually running. You can see every time I do a keystroke here, hopefully you see the spinner kind of like shows up briefly and then fades out, which is not what I wanted. Or if I manage to actually finish the form and hit the login button, we see some weirdness going on where they're kind of overlapping, and then all of a sudden both views are gone, and like what's going on there. Essentially, what is going on is with this model where lots of updates are being published at once, you can get into some corner cases which you have to consider ahead of time. And I actually would like to propose 3 kind of principles or tenets which would make a good animation in this world, which are that they should be reentrant, continuous, and smooth. Let's look at each of these. So the first up, reentrant, is a fancy computer science word for essentially that your function should be able to be interrupted and called again at any time. So essentially, we're saying if we're in this state where a new model can be published at any time and you're observing it, if you're running animations which also take a period of time, you need to be prepared for a model being published while the animation is still running. You need to be able to respond to that safely. The second one is continuous. If you look at this example of an animation here where this view is changing scale and color as I touch it, everything looks fine if I kind of touch it and it scales to completion, I let go and it scales back to normal state. But if I touch kind of rapidly, you can see it's jumping in scale and color. And this kind of discontinuity is very jarring. It can be very kind of like abrupt, this change to your users, which doesn't lead to a very pleasant user experience. Essentially, animations are all about smoothly changing a value over time. Right? That's kind of what an animation is. If we're not kind of prepared for this new value coming in at a certain time, you can have something like this, where we're midway through one curve, and then suddenly we jump, and we have this discontinuity, which leads to this poor user experience. And the last tenet I want to propose is one of smoothness, by which I mean, take this example where I'm animating a view to either the top left or top right, depending on pushing this button. If now I hit the top right button twice, you can see it slows down and then animates again. Because a new event came in, it kicked off a new animation, but because each animation had the same duration, it leads to this kind of like discontinuity in the velocity. So it slows down, and this kind of looks kind of terrible. Similarly, if I try and retarget it, so it's going one way, and then I send it off to the left and then to the right, you can see it just kind of stops suddenly and then reverses direction. Now, nothing in the real world kind of like has this instantaneous change in direction or velocity, and so this feels very unnatural to us. So let's look at solving these problems in our code. So first up, let's take a look at that continuous property that it jumped midway through. And you can see here that I've kind of made some assumptions, really, that when you want to show something, that I'm going to animate its visibility, its alpha property, sorry, from 0 to 1 or 1 to 0. So this is kind of like making an assumption of the current value. What we can do with animators instead is just remove that initial value. So just say animate to this value. And the way the object animator property system works is the property here, alpha, both tells you how to set the kind of animated value on the view as well, but also offers how to get it. So if you omit the from value, it will read the view's current alpha and it will start from there, which is what we want. We don't want the value to jump around. So that was easily solved. But let's take a look at the reentrant problem. That's slightly thornier. So the reentrant property essentially is that we want to be able to call this at any time and not have any kind of side effects lingering around. So essentially what we need to do is clean up after ourselves. We need to kind of cancel any running animation that's going on. But if you look at this code here, we're not actually holding a reference to the animations, right? We just create them and call start and then forget about them. There's no reference held onto it. So what we can do is fix that. Actually, first before that, let's not run an animation if we don't need to. So in that instance where I was typing, and it was like all the time saying, oh, I want the spinner to be invisible, it was always running that animation. But we want to actually skip that animation if you don't need to. So here, what we're simply doing, we're saying if we're targeting, like if we're going to go fade it out to 0, if it's already faded out, just return early, so bail early, so short circuit the method. But yeah, if we wanted to cancel a running animation that's kind of like mid-progress, then we need to kind of store it somewhere so that we can have access to the animator to cancel it, such that we can, when a new invocation comes around, we can cancel any running animations before setting up the new animation. So we could do this, we could store it somewhere, but where would you store it? These functions are essentially kind of pure functions, they're kind of static. So the only option really is to store it really in the view itself. But View already offers such a method for this. It actually has something called a view property animator, which is what's returned when you call view.animate, which allows you to do this kind of get access, retrieve any running animations. So if we swap out our code from using object animator to using view property animator instead, then we get some of these properties. So what happens here is when you call view.animate, if there's already an animation running over that same property, it will be cancelled for us, and then the new animation will be run. So that's exactly what we want. Even more, view property animator offers this with end action API, which takes a runnable. So the cool thing about this is this action will only be invoked if the animation runs to completion. It won't be invoked if the animation is cancelled. So if a new value comes in, then the old animation is cancelled, and the action only runs if it completes, which is exactly the kind of properties that we want. There's still a few problems with this system here, though. So what happens if we're midway through an animation? Well, we just said that it's going to cancel the previous animation and run a new one. So that's going to violate our smooth property, because if we're already animating to the right target value and a new value comes in, it will still kind of cancel it and start again, so you'll get this kind of like stutter change in it. We could, for example, store the current value that the animator is kind of currently animating to, and if a new update to the same value comes in, we could perhaps skip that update. But that's not going to help us out in the case where we're trying to retarget to a new value that comes in midway through an animation. So how are we going to solve this problem of smoothness? Well, there's actually a library out there which I think a lot of developers haven't really paid much attention to, which is the physics-based property animation system. And I think maybe people have skipped it because we look at some of the samples or demos or even our developer documentation here, and they see things like these bouncy animations and think, hey, that's fine if I want to make a bouncy effect, but it's not for me for general UI kind of animation. But that's a shame, because you can actually very easily turn off the bounciness, and what's left is a very powerful physics-based system which has a number of properties which are useful for these kind of cases that we're trying to solve. So for example, if we return to our square going to the left or right, and we run it with a physics-based spring system underneath, because it has a physics system underneath it, when you retarget it to a new value, it maintains things like the velocity for you, and it gives us these properties we're looking for where if you try and go to the same place twice, it maintains the velocity, even though it's starting a new animation. Or if you retarget to another destination, it slows down and changes direction very, very smoothly by maintaining the velocity for you. So if you haven't looked at Springs, the API looks very similar to the animator system, where you have a subject being animated, a property which you want to animate, here the translation X, a target value, and then you call start on it. But for me, the real power comes when you, instead of using start, you use this animate to final position API. What this does is if the animation isn't started, it will just kick it off. But crucially, if an animation is running, then it will retarget it, and this will do that magic of maintaining the velocity for us and updating the target value. So the key thing there was if the animation was already running. So we want something like the view property animator we saw before, which held on to a reference to any running animation such that we can access it and cancel it or update it. But unfortunately, Vue doesn't have a get spring method or like Animate has, so that it can return you a handy one of these. So let's build one. So this is an extension property I've been playing with, extension function, excuse me, adding on Vue, whereby you pass it a property, a view property you want to animate. So this is things like translation X or alpha or so on, and it will return you a spring animation. And what I do is I stash the running spring as a tag on the view, so it can hold on to it. So going through it here, what I do is I map the property to a key, such that you can store it in the tag, and then try and retrieve it from the Vue's tag system. So if there's one already running, we'll get access to that. Or if there isn't one already set up, already stored, then we'll create a new spring animation and store it in the Vue's tag, and then return it. So a handy little, small extension function like this that helps you get access to a spring for a given view. And what that means is that we can, at the call site, have a nice clean something like this, or you just do view.spring for the translation X. And crucially, this will either return you a new spring animation or one that's already running, which is exactly what we want. And then we can use that animate to final position syntax to update a running animation. So what might this look like in our binding function that we were talking about? So here we were using the view property animator. We can sub this out, use the extension function, and grab access to the, or create a new spring and animate it to the final value that we want. The eagle-eyed amongst you might have noticed we regressed some functionality there. We lost the end listener. You can, of course, still do this. The Spring animation system has listeners as well. So here we can add this end listener to set the visibility to gone at the end. But there's a slight caveat in that in order to remove a listener, which we would have to do first ahead of time, you need a hard reference to it. You can't just call clear or any such method like this. So we need to store the listener. Again, I'm using the view tag here as a handy way to stash it in the view, such that before setting up a new animation, we can cancel any previous end listeners. So it's a bit of that. You have to be a bit careful the way you write these animations, that you have to be careful that they are reentrant especially. But the nice thing is that you kind of write these functions. There's only like a handful of these functions you need to do. You need to write one for like alpha, one for translation, one for scale, whatever it might be, and you stash them in a library. And then you can use them throughout your code base, use them in a number of places. So you just write them a couple of times correctly, and then use them throughout. Now, looking at springs, I kind of simplified the creation a little bit. So just like when you create an object animator or view property animator, you probably customize things like the interpolation or the duration. Springs don't really have those concepts because they're physics-based. They have kind of things that describe the physics system underneath it. So as such, you probably want to do customize the spring forces to set the damping ratio and the stiffness. So the damping ratio controls that bounciness we just talked about, and the stiffness controls how fast the spring moves to equilibrium state. So if you don't set these, you'll get these default values, and this kind of medium bouncy or medium stiffness, which is kind of what we saw in the example before. But I found there's some kind of default values that are generally applicable for UI work. So I added these to the extension function to make it very easy to get this kind of some default behavior that works well for most cases. So turning off the bounciness altogether and setting a slightly higher stiffness ratio. But because they're default parameters, it makes it super easy that you can just pass an alternate value at the call site if you want to customize an animation to make it slightly snappier, for example. So to give you kind of a real example of this, we're going to take a look at a RecyclerView item animator. So RecyclerView does a lot of stuff for you, right? So using diffutil and fine-grained adapter updates, it'll give you free animations, essentially. So in this example, I've got a grid, and then when I hit the shuffle button, it's moving some items around. So this is with the default item animator, and you can see it's got that kind of, discontinuous or not very smooth, sorry, it is continuous, but not very smooth animations when items come in. We can sub this out for this kind of spring-based system, and we can see that when the new updates come in, you can see that they smoothly animate to the final place. And this might seem like a kind of toy example for slides, but this is probably quite close to what's actually happening in your apps. How many apps grab stuff from the internet and shove it into a RecyclerView? And this is obviously like an asynchronous operation, so updates can come in at any time, or maybe you scroll and new information is coming in. By kind of thinking about making the animations that happen when this asynchronous data kind of comes back as smooth as possible, you can really kind of improve the user experience in your app. So this is a kind of a slight simplification of the code because extending default item animator is a little bit involved. But essentially, it comes down to setting up some translations on some views, and then when you want to animate it, you just animate those translations back down to 0. So we just use that exact same extension function we looked at before to create or grab an already running spring animation over the translation properties and animate them down to 0. And this is essentially what it gets to give you that kind of nice, smooth behavior. And I'll put this in the gist in case anyone wants to take a look. So we just looked at a kind of general approach to how to animate view properties. But view properties aren't the only things that you want to animate and have respond to kind of new states of your application. It's going to take a look at a few classes that you should be aware of that can help you to do this in other parts of your application. So drawables, for example, often you want to set their state. But you don't always want that to be just kind of like a static state. You sometimes want to animate those changes. I think everyone is familiar, hopefully, with this StatelessDrawable class. So you can define in a checked state, I want this drawable, and in an unchecked state, I want that drawable. But I don't think as many people are super familiar with the animated version of this. So this was introduced in Lollipop API 21, but it's also part of Jetpack, so you can use it back to 16. So this lets you, in addition to those states, it lets you name those states in order that you can provide a transition when moving between any of those states. And these transitions, the drawable here, can be in the form of either an animated vector drawable or an animation drawable, kind of like a frame sequence. So then the calling code becomes super simple. So in your binding, you just have to set, say, the check state to something in your UI model, and the class itself, under the hood, will take care of running the transitions that you define for it. So this looks like something like this. So this is from the Android Developer Summit application, where you're tapping the start, and rather than it just changing, you can get this kind of like scale animation. But it can be used like pretty much everywhere you can use drawables. So in the bottom navigation view, for example, when you select a section, it gets to the checked or selected state, I forget which, gets set, and we can set a transition for running between those states. So you get these nice little animations as you enter the state. And all of this is completely declarative. So all I have to do is set the icon to an animated stateless drawable like this, and I'll get this behavior. I don't have to maintain the state or worry about what state it was in. It will get cancelled for me, or the new one will get set for me automatically. And we can actually extend this behavior to produce some quite powerful effects. So this is the book reserve a spot button from the Google I/O application, which I guess everyone in this room has probably used. So like reserving a spot in a session is quite a critical kind of action, right? We don't want to just update the UI optimistically and say, yeah, you've got a ticket, when you might not have. We want to actually do a network request and confirm that you've got a seat before we tell people that, or let you know if you've been waitlisted or so on. So there's quite a lot of information being communicated in this button. But this is actually powered entirely by a single animated stateless drawable. So you can see here that we have some states in there that have the different drawable states. But you might be looking at that and thinking, what's state reserved or state waitlisted? I've never seen those on Android classes before. That's because I'm not sure how many people are familiar that the fact that you can actually add your own states to views, which can be super powerful if you want to then use it in conjunction with this technique, like an animated stateless drawable. So this can then power running the right transition whenever you set one of your custom states onto a view. The way you do this is it looks quite similar to defining custom attributes for a custom view. You can define it in an attrs file, the states you want to support. And then we actually wrapped up this behavior into an enum because there were a few things we wanted to change when the button changes state. So not just the state, this kind of this attribute state, but also we wanted to change the content description or some text that gets displayed with the button. So we wrapped this all up into an enum of states, setting this the attribute state as well as these other things. Then we extend the app-compat button, image button class in this case, and do a couple of things. First, we expose a property, which is one of these enum values. And crucially in that, whenever that changes, we call refresh drawable state. This is your hook into the view system to say, hey, my state has changed. And that, in turn, will kick off the later updates to actually run the transitions. The other thing you have to do is you have to override onCreateDrawable state, which is essentially how you're telling the system what state you're currently in. So here you have to call this merge drawable states method and pass in your current state. This is the kind of attribute resource, which if I expand it out from the enum value is this int array of the state that you're currently in. So by doing this, we can get some pretty powerful behavior. So we can have these transitions between all these given states. But as you saw, this can get quite quite a lot, because there's 6 different states. If you want to be able to animate between each and every one of those states, you basically end up with an n by n problem. So you'd have to kind of define 36 different transitions there, which sounds pretty hard. So what we did instead is we had a policy of always going through an intermediary state, this pending state where you see the hourglass going round and round. So as such, if you wanted to go from reservable to reserved, you always go through this intermediary state. And that made us that cut down the number of transitions that we had to run from n by n to just 2n. So we only had to write 12 animated vectors. Luckily, I like writing animated vectors. If you're lucky enough to be running on API 23 or beyond as your min SDK, then you can use the platform's AnimatedVectorDrawable class instead of the support libraries one, which also supports reversing So you can only write n, just 6 different transitions, and have them reverse when going in the opposite direction. But I guess most people aren't in that world just yet. One note about doing this kind of thing is that we wanted to have this nice intermediate state where it's like animating the hourglass. One current limitation of the AnimatedVectorDrawable class is that you can't set a repeat count on animator set. You can only set it on leaf animator object animators. So here, where I'm setting the repeat count to -1, which is infinite, so just infinitely animate, you have to be able to structure animations in such a way to achieve this. So how does the AnimatedStatelessDrawable help us against these kind of goals, which I set out for my animations? They only really tick one box for me here. They're Reentrant, so it maintains the state for me. So if I enter into a new state, it will cancel everything, and it will start the new transition for me automatically. It's neither continuous or smooth, so it won't kind of, like if you're halfway through an animation, do some kind of magic to move from that halfway state to the end state that you've defined. But I think this is pretty useful for a class which is out the box. You don't have to write any code, essentially. You just have to provide different transitions, really, between the states. So it's a really handy class to have in your tool belt if you need to animate the transition of drawables. Closely related or similar concept, really, to AnimatedStatelessDrawable is the StatelessAnimator, which lets actually do similar things for views. So for example, in this application, I have some kind of threaded conversation. And when you select a single comment, I wanted to have this kind of transition where I animate the elevation and the background color of the selected comment. And this is entirely declaratively powered by the StatelessAnimator class. So a StatelessAnimator is essentially a selector where within each item tag, within each item which is a given state, you can define these child animations to be run. I don't know why it's not an animated selector, but it's a selector anyway. So here you can see I'm running an animation over the background color and the translation Z property whenever you go into a certain state. And here, I just want to point out, you don't have to create your own view states if you don't need them. So here we just reused the Android activated state, which is available on every view. So while defining custom view states is super powerful, if you have multiple states you want to move into and you want it to be more meaningful and semantic, you can just reuse some of the Android states. So StatelessAnimator, how does this kind of like score on our chart? So just like AnimatedStatelessDrawable, it's Reentrant, so it will maintain the state. So if a new state comes in, it will cancel anything that was previously running and move you into the new state. It's kind of semi-continuous. I'll give it like half a mark here. And that really comes down to the fact that it's just running these object animators. And just like we looked at before, you can provide a from value and a to value. So just by omitting the from value, it will try and query the current value in order to run it. But I said try, because this is essentially a kind of reflection-based approach. So View has a getTranslationZ method on it, so it can query the translationZ, and so translationZ will be continuous. But there is no getBackgroundColor method on View. Essentially, there's a setBackgroundColor method, which is a convenience method almost that takes that color and coerces it into a color drawable and sets a color drawable on the view. But there's no getter for it. So you have to be a bit careful about, if you want to make this continuous, about using properties which are animatable, that you can read their current value in order to get this continuous property. And the last bit I want to talk about is an approach to doing custom view animation. So let's walk through an example of what I mean by that. So in the Google I/O application again, we have these filter screen where you can customize the schedule to see the topics that you're interested in. You're just interested in Android and sessions, right? So this is a custom view because we want to have complete control over the rendering of it. And there's a few things going on with this animation. So when you select it, there's the kind of the colored circle both increases in size as well as we animate its center to be in the center of the chip. We animate the text position, and then we also scale up the drawable, which is that clear X at the side. So you could think of a way of writing this as a custom animation whereby you create animators for each of those things which is changing, and run those animations individually. So an animation for the circle radius, one for the circle center. And then you could perhaps put them into an animator set and try and control them and orchestrate them like that. But instead, the way we went for this is we instead have a single progress property, which is just a float, which runs from 0 to 1. And we just run a single animation over that progress property. And then what we do is we drive the rendering to query that progress property. So for the circle radius, for example, we say, what radius should I be from between this start value and that end value for a given progress. And if you haven't seen the lerp function before, it's a very common animation kind of utility, which means linearly interpolate, which will do just that. So between this value and this value for a given progress, what should I be? And the kind of key takeaway here is that if you have this single progress function, and then you can just animate it very easily. So you can hook this up to a spring, like we looked at before, and have this entirely be continuous and smooth by running spring animations and being able to retarget it to something else, rather than having to try and orchestrate multiple animator sets, which can be a pain. Or you could hook this up to a gesture, perhaps, and do something an animation responding to a scroll, or even hook this up to something like motion layout, which lets you animate a custom property based on scroll position. So those are my three kind of tenets, I think, that make up a good animation that is going to survive in this kind of reactive world. But this is really kind of an ordered list for me. Essentially, you can think of it as Crafty's hierarchy of animation needs, where being reentrant is kind of about correctness. If you aren't reentrant, if your animations aren't cancelable and work in the right way so that it can be recalled, then you're going to end up in the incorrect state. So this is like table stakes. You have to get this right in order for animations to survive in this reactive world. Continuous is all about, I think, having a smoother user experience, so values don't jump unexpectedly, which can be very jarring. And smoothness is almost like this stretch goal for me. It's like the icing on the cake, that rather than just having things abruptly change velocity and change direction, then it can be a much nicer experience to have it do it in a smooth manner. But I think it's worth striving for, because what's the point of animating it if you're just going to kind of half-ass it? So that's my conclusion. Really, like that. I think it would be a shame if we, in this reactive world, if we were just to give up on animations. And I think that these principles can really help you hold them in mind in making better animated apps. Thanks very much.